Hi, welcome to Lesson 7.4, Properties of Special Parallelograms. Now, to prepare for today's lesson, you are going to need two pieces of half sheets that are blank, or two blank half sheets. So the first half sheet, you are going to glue it onto page 210. So page 210. Okay. The second half, you're going to glue it on page 211. Okay, right there. And we're using these just to cover up anything that's under this. Turn to page 212. And you're going to do problem number 1 here on page 212. Problem number 2 there. Problem number 3 here at the bottom. Turn the page. You're going to do problem number 4 here and problem number 5 right there. So we're going to go back to the exploration in just a bit. Let's start with page 212. Let's look at these definitions. All right, so in the previous lessons, we have talked about parallelograms. Now, these are the 3 special types of parallelograms that we're going to discuss today. So the first one is the rhombus. A rhombus is a parallelogram with 4 congruent sides. Okay, so a rhombus is a parallelogram with 4 congruent sides. A rectangle is a parallelogram with 4 right angles. Now, if you were to combine those 2 properties, you end up with a square. So a square is a parallelogram with 4 congruent sides and 4 congruent angles. So is a square a rhombus? Yes. Is a square a rectangle? Yes. Is a rectangle always a square? No. Is a rhombus always a square? No. Okay. So we have to make sure that we get those clear. Okay. Basically, these 2 merge together, you get this one. Now, today's lesson has a lot of theorems, and they're all called biconditional theorems, meaning that the theorem can be split into 2 separate theorems. Okay. So the first one, now we're not going to be able to prove every single one of them, but we are going to prove a few. The first one is a quadrilateral is a rhombus if and only if it has 4 congruent sides. So a quadrilateral is a rhombus if and only if it has 4 congruent sides. So if you see a quadrilateral with 4 congruent sides, okay, so if a quadrilateral is a rhombus if and only if it has 4 congruent sides. So any quadrilateral that has 4 congruent sides is going to be considered a rhombus. Rectangle corollary. A quadrilateral is a rectangle if and only if it has 4 right angles. So if you see a quadrilateral with 4 right angles, then it's going to be a rectangle, and vice versa. The next one, the square corollary. A quadrilateral is a square if and only if it is a rhombus and a rectangle. The rhombus diagonal theorem. A parallelogram is a rhombus if and only if its diagonals are perpendicular. So that means that if you have a rhombus, the diagonals are going to be perpendicular. And we are actually going to be doing a proof for this one. Not here on the other page. Okay, I shouldn't put it right there. Okay, so we are actually going to be proving this one. Okay. Now, a parallelogram is a rhombus if and only if each diagonal bisects a pair of opposite angles. So that means that these angles right there also get bisected. Okay. So that is actually the second one we're going to prove. So we are going to prove this one. Okay, so in other words, if this is a rhombus, the diagonals bisect these 2 and bisect these 2, and this one and this one. And the third one, not third one, but the last one here, the rectangle diagonal theorem states that a parallelogram is a rectangle if and only if the diagonals are congruent. That means that this is congruent to this. If these two are congruent, then it's going to be considered a rectangle. So let's go ahead and start proving these two. So please go back to page 210. Now brace yourself because some of these are going to be a little bit long and confusing. Okay, so I'm going to try to go slow so you guys can keep up with me. All right, so the first one, now we're not going to prove this in a biconditional form. We're only going to prove it one way, not two ways. Otherwise, it's going to be more complicated. So we're going to prove the rhombus opposite angle theorem. And basically it goes like this. If you have a rhombus, now remember, a rhombus is a parallelogram that has opposite sides congruent. Okay, so we know that already. So given, okay, that A, B, C, D is a rhombus. Okay, what do we need to prove? Okay, we need to prove, now let me give these a name. A, B, C, D. I need to prove, okay, that BD bisects both angle D and angle B. Okay, so I need to prove that. All right. It looks complicated, but honestly, it really is not. Okay, and there's multiple ways of doing this. All right, so first step. A, B, C, D is a rhombus. That is given. Okay, so what we're going to do is this. Okay, we know that these two sides here are making an isosceles triangle, therefore the base angles are going to be congruent. So angle 1 and 3, they're going to be congruent. I'm calling it 3 because I'm calling this one here 2. 2 and 4. Now because this is a parallelogram, 2 and 3 are going to be congruent by alternate interior angles. And also 2 and 4 are going to be congruent by the base angle theorem. So therefore, those are going to be bisected. All right. So let's see. Second thing. Okay. We know that AB is congruent to BC, congruent to CD, congruent to AD. Okay. Definition of a rhombus. All right, now because these angles here are going to be congruent, angles 1 and 3 are congruent by the base angle theorem. Angle 1 congruent to angle 3 by the base angle theorem. 4. Okay, we know that angle 3 is congruent to angle 2 and that's by the alternate interior angle theorem. Okay, so therefore angle 1 is congruent to angle 2. Okay, by transitive property of congruence. Now, we also know that angle 2 is congruent to angle 4 again by the base angle theorem. And therefore, again, by transitive property, well, actually, no, we don't actually need that because 1 is congruent to 2, 2 is congruent to 4, okay? And 2 is congruent to 3. It's like a double transitive property. Okay, angle 3 is going to be congruent to angle 4. Okay, so let me repeat that again. 1 is congruent to 2, 2 is congruent to 3, therefore 3 is congruent to 4. All right, so it's again another transitive property. All right, so now that we have angles 1 and 2 and 3 and 4 congruent, now I can actually state that BD is the bisector. Okay, so BD is an angle bisector of angle D and angle B. Definition of an angle bisector. Okay, sometimes you might have to look at these for a while and try to make some sense of every single step. And if you need me to explain these with a little more detail, I'd be happy to. All right, let's go ahead and prove the next one. Okay, please turn to page 211. Okay, so on page 211, we're going to prove the rhombus diagonal theorem. Okay, so pretty much if you have a rhombus, okay, and remember the rhombuses have congruent opposite sides. What they want me to prove here is that in this rhombus, okay, these diagonals are going to be perpendicular. So I have to prove that they're going to be perpendicular. So given rhombus ABCD, what do I need to prove? Okay, I need to prove that AC is perpendicular to BD. That's what I need to prove. So how am I going to do that? It seems like it's going to be complicated, but honestly, it is not. Okay, one of the things that you have to remember here is that the diagonals bisect each other, and we knew that already. Okay. Oh, wait, I made a mistake on these. These are all the same. Because the rhombus. Yeah. Why did I put 2 of them? I don't know. All right, so here's the thing. This side right here is congruent to this side because the diagonals do bisect each other. Okay. AE is going to be congruent to itself. It's going to be congruent to CA also. This one right here, we're going to call this point E. But we really don't really need that. Okay? So how are we going to prove this? Well, here's the thing. These two triangles are going to be congruent by side, side, side. And these two angles right here, this one and this one, not only are they a linear pair, they're also, they're supplementary and they're congruent. So therefore, that's going to make them right angles, making AE perpendicular to BD. So that's the strategy that we're going to use. Okay, so we have rhombus ABCD. That is given. Okay, so because it is a rhombus, you're going to have segment AD congruent to segment AB. So AD to AB. Okay. Also, you have DE congruent to BE. Because remember, the diagonals bisect each other. So this is called, well, let me go back and put this one. Definition of a rhombus. All right. And DE congruent to BE because of the parallelogram diagonal theorem that states that the diagonals bisect each other. So now we have AE congruent to AE because of the reflexive property. It would help if I number these. Which now you are going to have two triangles congruent. Okay, triangle DEA congruent to triangle BEA. Why? Because of the side-side-side congruence theorem. So boom, those two triangles are congruent. Okay, so because those two triangles are congruent, those two angles by CPCTC are going to be congruent as well. Okay, so you're going to have angles A, E, D congruent to angle A, E, B. Why? By CPCTC. But also, they are also a linear pair. So angles AED and angles AEB are a linear pair. Okay, definition of a linear pair. So because they're congruent and a linear pair, that means that they're both going to be right angles. Okay, so they're both going to be right angles, making those two lines perpendicular. So AC perpendicular to BD. Definition of perpendicular lines. All right, so where did that come from? Look, these two angles are both, and when I'm talking about those two angles, I'm talking about this one and this one. Those two angles right there are not only a linear pair, but they're also congruent by CPCTC, which makes them right angles, which means, by definition, those two lines are going to be perpendicular. All right, let's go ahead and begin our examples. All right, so let's look at example number 1. For any rhombus Q or ST, decide whether the statement is always or sometimes true. What I do suggest you do is draw Q or ST, and they tell you that this is a rhombus. So let's draw the rhombus. Okay, Q, R, S, and T. Now remember, we got to remember all the theorems we just learned about rhombuses. Okay, so Q congruent to S. Well, let's identify it. Q and S, they happen to be opposite angles. So remember, this is also a parallelogram. So rhombuses follow all the properties of parallelograms. So is this always going to be true? Yes, it will always be true, because they're opposite angles. Let me draw the second diagram. If you want to do one diagram for both, knock yourself out. Will Q be congruent to R? Well, it's not going to be always, definitely, because there are some cases where, there's a lot of cases where it's not. But it's going to be a sometimes. When is a case where Q and R are going to be congruent? Well, they can only be congruent if they are a right angle. So this is only going to happen when this is a square. So this is going to be sometimes. Sometimes. When? When QRST is a square. Because if this is a square, it's going to look something like this. QRST, where all the sides are congruent, and these two right there are right angles, along with these two. So this is the only occasion where this is going to be true. Okay, and that is example number 1. Let's look at example number 2. It says classify the special quadrilateral. Okay, looking at this, you see that all the sides here are congruent. So one of the theorems that we did learn is that if you have a quadrilateral where all the sides are congruent, then it's going to be a rhombus. Okay, so the only thing that we know here by definition is that this is going to be a rhombus. So we're going to call this a rhombus. And because it is a rhombus, it's also going to be a parallelogram. And those are the 2 classifications that you can get for this problem. Let's look at number 3. Okay, it says find the measure of the numbered angles in the rhombus. All right, so let's remember this is a rhombus, so which means that the opposite sides are going to be congruent. We know that the diagonals are going to bisect each other. We also know that they're going to bisect each other, but they're also going to be perpendicular. So this angle right here is going to be perpendicular. So let's go ahead and make the list. Measure of angle 1, measure of angle 2, measure of angle 3, measure of angle 4. Okay, so we know angle 1 is going to be 90 degrees. So how are we going to figure out the other one? Well, we got to remember one thing. This angle here is congruent to this angle right there. So this is 61. Now remember, these angles, angles A and C, they're opposite angles. So therefore they should be congruent. So that means that angles 2 and 3 also have to be 61. Also by alternate interior angles. So angle 2 is 61 and angle 3 is also 61. So this right here is 61. So in order to figure out angle 4, all you have to do, because this is a right angle, is subtract 90 degrees minus 61, and that gives you the measure of angle 4. So 90 minus 61 gives you 29. So the measure of angle 4 is 29. And that is example number 3. Let's look at example number 4. And there's 2 parts to this one. So let's look at the first part. You are building a frame for a window. The window will be installed in the following opening. The opening must be a rectangle. Given the measurements in the diagram, can you assume that it is? Well, here's the thing. The only thing that you know is that the opposite sides here are going to be congruent. So you know that for sure this is going to be a parallelogram. So the thing is that in order for this to be considered a rectangle, you will need to know if the diagonals are going to be congruent or not. Okay, and according to this, you have no information that tells you that. So here, you can only assume that this is going to be a parallelogram, and that's it. Okay, you cannot assume that it's going to be a rectangle. Now, in part B, it says you measure the diagonals of the opening, and the diagonals are 54.8 and 55.3. What can you conclude about the shape of the opening? So remember that in order for a parallelogram to be considered a rectangle, okay, the diagonals have to be congruent. So here, the diagonals 54.8 and 55.3 are not the same. So therefore, there is no chance this is going to be a rectangle. So this will not be a rectangle. And mainly, it's not going to be a rectangle because the diagonals are not congruent. So the diagonals are not congruent. That's example number 4. Let's look at example 5. Okay, in example 5, it says QRST is a rectangle. QS is 5x minus 31 and 2x plus 11 equals RT. So remember, since this is a rectangle, the diagonals are congruent. So those two are congruent. So the length of QS is 5x minus 31, and the length of RT is 2x plus 11. So I have to equal them together and solve for x. So you subtract 2x, you get negative 31 equals, let's see, oh wait, no, wrong side. 3x minus 31 equals 11. Add 31 on both sides, and you get 3x equals 42. And when you divide that by 3, you're going to get 14. But that is not the answer. What we need to do is go back and substitute the 14 into either one, QS or RT. So I'm going to do it in RT. So RT, which is 2x plus 11, I'm going to substitute that, 2 times 14 plus 11. So 2 times 14, that's 28, plus 11, that's going to give me 39. So RT is equal to 39, which is the same as QS. And that concludes our lesson for lesson 7.4. Thank you for watching, and don't forget to subscribe.